This is a 1957 Bolens Ride-a-Matic tractor, and I'm going to talk about how the drive hubs work. I took the hub off and cleaned up the parts. This hub was fully packed with grease. You can see the teeth at the top there. I didn't want to clean out that grease to show you what the teeth look like, so here's a picture I had of another hub from the same kind of tractor. This is the part I would call the drive pawl. It toggles back and forth on this pin depending on which direction the axle's moving, and one end or the other engages into the teeth on the inside of the drive hub. If you look back here, it has a spring clip type thing, and it's trapped behind a little pin there. The spring clip type thing comes around and captures a pin on the drive pawl, and it wraps all the way around the other side where it's trapped behind another little pin. I can move this pawl back and forth, and the spring clip type thing moves with it. If you look down here, you can see the part that the spring clip thing is gripping on don't rotate. Now the camera's on a tripod, and I'm going to turn the front drive sprocket to make the axle turn. I'm moving in reverse a little bit. That drive pawl is extended out to where it would engage a tooth to move the hub in reverse. Now I'll move the axle forward. See, the axle is moving the drive pawl pivot point, but that snap ring looking thing, which is gripping the housing, holds the outer pin of the drive pawl in place. That toggles the other end of the drive pawl out where it would engage a tooth to move the hub forward. Once the tooth engages the hub, the pawl can't toggle anymore, and the snap ring thing just moves along with it. When you reverse the drive, the axle starts turning, and the drive pawl toggles the other way to engage a tooth to drive in reverse. The axle is a solid bar, and this same mechanism is on both wheels. Each side grips the hub as it needs to when the axle moves. If the tractor is turning, the wheel that moves faster simply pushes the pawl out of the way, so there's no binding like you'd get if it was constantly locked. The axle was turning clockwise, so the drive pawl would be forced to the left like this. But if you were to push the tractor forward, the axle don't move. The teeth on the drive hub pushes down on whichever end of the drive pawl is engaged, moving it to the middle position so the tractor can easily roll forward or reverse. In the middle position here, neither end of the drive pawl is touching a tooth. Now when you stop pushing the tractor, or rolling downhill maybe, and you move the drive lever to rotate the axle forward, the drive pawl moves out and engages the hub to push it forward. It's a pretty ingenious mechanism. One thing you need to be ready for on these: when you're driving down a hill, the tractor will freewheel forward faster than the drive's pushing it, so you have to ride the brake to keep it from running away. When driving uphill, that's not a problem because the axle's driving the wheel, so the pawl would stay engaged. Alright, that's it.